So the first step in validating a new built hardware is to validate the RF layer or the PHY layer, right? In our built access point based on the Raspberry Pi 5 with the 7915 MediaTek radio, we're gonna be looking today at the TX power as one of the first metrics that we're gonna be measuring and verifying on this new built hardware. So we can see here we have the 4 radio chains connected through the jumpers, RF cables, and connectors to the IQ LitePoint, which is going to be our measuring tool to look at the spectrum, power levels, and constellation. If I would move here to look at the AP console, right here we have basically one radio connected to that LitePoint, set to channel 149, bandwidth 20 megahertz, and TX power of 20 dBm. If I would move here to the LitePoint measuring graphs, we can see here the graph at the bottom that shows the power versus time. We have the capturing window to set to 200 millisecond, so we can actually see 2 spikes. Each spike is 1 beacon. And we can see here there's like 4 signals, which is like 4 chains. At the one at the top is the spectrum. We can see the 20 megahertz spectrum, the OFDM spectrum basically. And we can see all 4 signals imposed on top of each other. If we move to the right side of the graph, we can see here the plot at the bottom, that's the constellation. So we can see here there's like 2 points on the graph, which represents the PPSK because we're sending beacon. And at the top, we see this table that actually shows the TX power. So we can see the power, which is the TX power per chain. We can see the preamble power, and we can see the peak power. So the interesting part is the power per chain is around 11 per 33 dBm, which is completely different from the number we saw from the console at 20 dBm TX power. The truth is, like, when you set your driver to 20 dBm, that means that you're setting the total aggregated TX power and not the power per chain. So what we're looking at right now is the power per chain. However, if we're using the logarithmic scale and the dB, so 20 dBm and minus 6 dB, that will give us 14 dBm per chain. So what we're looking at is still way less than the what is supposed to be, which is 14 dBm. If we remember, the chains connected through jumpers, connectors, and RF cables, and that's amount for around 2.5 to 3 dB of total loss. If we do the math, we can see that that compensates exactly for what we're missing here, around like 2.6 something of dB of power, between 2.5 and 3 dB of loss. So we end up with a total of 11.3. We can also see the peak power, which is the peak to average OFDM peaks. Those are like fine. Those are like basically like very momentarily, and they don't they're not consistent. So the power amplifiers can deal with them. Right now we see everything looks to be healthy. We see like the expected power level. We see the expected modulation scheme, which is the BBSK. All 4 channels are imposed on top of each other nicely. That means that the power is balanced between all 4 chains of the radio, and there is no chain is transmitting more or less than all the others. The next step would be to validate performance, TX performance, by connecting clients and sending traffic on the uplink and the downlink.